In this video I will talk about crystal structures. There are a lot of parts in this video, but I will give you only the very important physical concepts for understanding the crystals. I think there are some questions you will ask them for understand exactly what I say. What is the physical concept of crystalline? Crystal structure? In which the atoms are situated in a repeating or periodic array over large atomic distances, that is, long-range order exists, such that upon solidification, the atoms will position themselves in a repetitive three-dimensional pattern, in which each atom is bonded to its nearest. When describing structures, atoms, or ions, are thought of as being solid spheres having well-defined diameters.
Now we talk about the unit cell.
The atomic order in crystalline solids form a repetitive pattern. Thus, in describing crystal structures, it is often convenient to subdivide the structure into small repeat entities called unit cells. Unit cells for most crystal structures are parallelepipeds or prisms having three sets of parallel faces. One is drawn within the aggregate of spheres. A unit cell is chosen to represent the symmetry of the crystal structure, wherein all the atom positions in the crystal may be generated by translations of the unit cell integral distances along each of its edges. Thus, the unit cell is the basic structural unit or building block of the crystal structure and defines the crystal structure by virtue of its geometry and the atom positions within. Convenience usually dictates that parallelepiped corners coincide with centers of the hard sphere atoms. Furthermore, more than a single unit cell may be chosen for a particular crystal structure, however, we generally use the unit cell having the highest level of geometrical symmetry. Geometrical symmetry. The atomic bonding in this group of materials is metallic and thus nondirectional in nature. Consequently, there are minimal restrictions as to the number and position of nearest neighbor atoms. This leads to relatively large numbers of nearest neighbors and dense atomic packings for most metallic crystal structures. Also, for metals, using the hard sphere model for the crystal structure, each sphere represents an ion core. This table presents the atomic radii for a number of metals. Three relatively simple crystal structures are found for most of the common metals: face-centered cubic, body-centered cubic, and hexagonal close-packed. Please subscribe and channel. Like it and share it to all they need to learn materials engineering. In this channel I will give you the easy way for understand exactly materials engineering. See you later in next video.